Okay, looking at part F, which is evaluating sums in sigma notation, um, which is kind of like that part D section, except we're going in the normal direction. In part D, I gave you the expanded sum and you had to convert it to sigma. Now we're going in the opposite direction where we are going from sigma notation into the sum. And what you have to remember is in sigma notation, this bottom thing right here tells you what you start with. I'm going to start by plugging in k equals 1, plugging in, my G's are jacked up today, 1 for k, and then we will plug in every number above that. So we'll go k equals 1, then 2, then 3, then 4, then 5, except we stop with this one. We'll stop at k equals 3, which means this one's actually going to be pretty quick. We're going to plug in 1, 2, and then we'll stop at 3. So we'll stop at k equals 3. So when I expand that out, if I plug in 1, 1 plus 2 squared is going to be 3 plus 3 squared, which is 9. And then I would plug in 2 for k. So this is k equals 1. If k is equal to 2, 2 plus 2 squared is 4 squared, which is 16. And then I'll plug in 3. 3 plus 2 squared is 5 squared, which is 25. And then what you're supposed to do is add them all together. People seem to forget that part. They think you just write out the first 3 terms and stop. But it's the sum. This sigma right here actually means sum. So once you find the 3 terms, you add them together. 9 plus 16 plus 25 is 50. So your final answer is the sum of all of those terms. Add them together. So there we go. So find all the terms and then you add them. Don't stop after you simply find the terms. You add them all together. And technically I should have a plus sign between them up here as well. So we're adding all of those terms together. Let's see. Let's try this one. We are going from negative 2. The formula is negative 2k plus 8. We are starting at k equals 1 and we end at k equals 8. So if I plug in 1 for k, negative 2 times 1 is negative 2 plus 8 is 6. Then I will add and I'll plug in k is equal to 2. Negative 2 times 2 is negative 4 plus 8 is 4. And then I'll plug in k is equal to 3. Negative 2 times 3 is negative 6 plus 8 is 2. Then I will add to that k is equal to 4. And we do this until we get to k equals 8. Negative 2 times 4 is negative 8, plus 8 is 0. And every once in a while you look up and you find a nice pattern. And the pattern I see here is that we are subtracting 2 each time. This is an arithmetic sequence where we are subtracting 2. And I also told you that if you could write your formula in slope-intercept form, and this looks a whole heck of a lot like negative 2x plus 8, that is an arithmetic sequence, and the difference is your slope. So this is arithmetic with the difference in negative 2. So I have my first 4 terms. I still need to go all the way to k is equal to 8. So I need one for k is equal to 5, k is equal to 6, k is equal to 7, and k is equal to 8. So I need 4 more terms. And I'm subtracting 2 each time. So I'm going to go 0. Then my next one's going to be negative 2. Plus, if I plug in 6, negative 2 times 6 is negative 12. Plus 8 is negative 4. My next one's going to be negative 6, and my next one's going to be negative 8. And then we add all of these numbers together. Do not stop by simply writing them out. We're going to add all of these together, and we will get an answer of negative 8. So the sum is negative 8. And this one's kind of nice because when you add, you have a 6 and a negative 6. They cancel. 4 and a negative 4 cancels. 2, negative 2 cancels. And then 0 plus negative 8 is negative 8. So sometimes you can see things that will cancel out. That's kind of rare, but whatever. All right, next one. 3 times all this stuff. Skills, man. 3 times that stuff to the k minus 1, going from 1 to 10. And this one is going to be a little bit tricky. If I plug in 1 for k, if k is equal to 1, I would have 3 times negative 3/4 to the 1 minus 1, which is 0. 3/4 to the 0, anything to the 0 is 1, so my first term ends up being 3. And then I need to add to that k is equal to 2, or 1. Wait, yeah, I started at 1, now I need to plug in k equals 2. So 3 times negative 3/4 to the 2 minus 1, which is 1. So that's 3 times negative 3/4, which is negative 9/4. And then I will add to that k is equal to 3. And 3 is where it's going to start getting ugly, because that's going to be 3 times negative 3/4, and 3 minus 1 is 2. Negative 3/4 squared, negative 3 squared is positive 9. 4 squared is 16. 3 times 9 over 16 is 27 over 16. Plus, and if I kept going, which I don't know, I'll do one more. If I plug in k is equal to 4, because I can do that one in my head. The others after that I'm not so sure. Negative 3 over 4 to the 4 minus 1 will be 3. 3 cubed is 27, but if you cube a negative, it remains negative, so negative 27. 4 cubed is 64. And what's going to happen here is my numbers, 3 times negative 27 is negative 81 over 64. My numbers are going to start getting very big, and I'm only on the 4th term. We still have 6 more terms because we have to go all the way up to 10. So at this point, what I'm going to start doing is seeing if there's a pattern, because if this is a geometric or an arithmetic sequence, there's a formula that we can use to find the sum without having to go through that excruciating process of writing out every single term. And this one does end up being geometric. There's 2 ways you could know that. You could divide these terms, and you'll see that each time you divide them, you will get the same answer, meaning there is a common ratio. You could also remember that a geometric series, the general formula for a geometric series is your nth term is your first term times r to the n minus 1, which is kind of what we're looking at. Not kind of, it is what we're looking at. We have 3 times something to the k minus 1. I just have k's instead of n's. But this number right here that's being raised to the k power, that is my common ratio. And the formula for the sum of a geometric series, therefore this is geometric. And the other way you could tell if it's geometric is you could find the ratio between any consecutive terms. For example, this one, negative 9/4 divided by 3 is going to end up being, punch out in the calculator and you'll get negative 3/4. If I plugged in these two, if I found the ratio between the 3rd and 4th terms, negative 81 over 64, if you divide that by 27 over 16, throw it in the calculator, you will get negative 3/4. You're going to get the same answer every time, even if I did the ratio between these two. If I found the ratio between the 2nd and 3rd terms, 27 over 16 divided by negative 9 over 4, throw that in the calculator, you will get negative 3/4. So this is a geometric series with a ratio of negative 3/4. And then I need the sum of the first 10 terms. I'm going from 1 to 10. If I write all that out, there's 10 terms. So the sum of the first however many terms, if it's geometric, is your first term times 1 minus your ratio to the n power over 1 minus the ratio. So I'm simply going to plug in. My first term I know is 3 because I've already plugged in 1 to get my first term. The ratio I know is negative 3/4, and the number of terms is 10. So I'll take all of that, and my sum of the first 10 terms is going to be 3 times 1 minus the ratio to the 10th power over 1 minus the ratio, which is negative 3/4. And we will throw this in the calculator. You just have to be extremely careful with your parentheses, because inside here you have to make sure that you catch the numerator all in parentheses and you catch the denominator all in parentheses, and we'll throw that in the calculator and we'll get a sum of, alright, our answer ends up being 1.6177. If you have a TI-89, I punched in a TI-89 and an 84. The TI-89 will give you the decimal answer, which is, it's so ugly. It's 424,000. 83. That's your numerator over 262,144. Your 84s, I have an 84 also, and I punched in and was unable to convert it to a decimal, or convert the decimal answer to a fraction. So I would accept either one of those two. But that is the sum of the first 10 terms of this sequence. I think that was the last one. Yeah.